Hello, welcome back. Yesterday I talked about arrays and how they're useful and how you can, um, I'll call this one containers, how you can kind of tap into how you can basically make a space in memory for a whole bunch of different pieces of data that you want to store, for instance. Um, what we did yesterday, and you could do it with any variable type, I'll do it with floats today, I guess, is numbers. I'll call my variable numbers, and let's say I have 8 of them, right? And the only difference between making a variable that holds one thing and 8 things is this square bracket with the number 8 after it. And then basically I have the word numbers as my variable, but any number between 0 and 7 in here will allow me to access those variables, and they will also allow me to type into those variables. Let's just make, for instance, the numbers 1 through 8 inside of this variable here, and we'll see if we can look at it in the debugger. So I'll make a for loop that starts at 0, because arrays are indexed at 0, meaning the first number for the first element is always 0. That's less than 8. And then there we go. And then I'm going to make the numbers, so I'll say numbers I, but I don't want it to be 0 to 7, so I'm going to say I plus 1, and that'll allow my variable to store the numbers 1 through 7. So if I run the debugger, I'm going to stop it here with a little stop sign, and just press beside the number I want to stop at, and hit the red play button. Going to allow me to stop my program and have a look at the variables as they go. Now I am missing my bottom here. Sometimes that can happen. The quickest way to fix it is you go to perspectives, and I'm missing my bottom because I'm in debugging mode actually, so that's not an issue. But you just click code blocks default. Just going to click that actually, and then it'll bring you back to where everything was. Or you can just go view, and under toolbars, or no, you just start clicking these ones. Manager and logs is really what the two that you want. Okay, and you could actually look at the start page and all kinds of stuff too. Okay, so I am debugging, so I'm going to go under watches, and I'm going to look at my, there's my array, and it holds the numbers 1 through 8. Yesterday I showed you that you could actually look at the memory of the computer as well here. And all you have to do for an array is actually just type in the name of the array. It will show you all the weird stuff that is in there. It doesn't even know. I wonder if you could tell it that this was a integer. These are all numbers. This is like the number 0 or the number 1, 2, 3, 4, 5. They're all in the memory, all in a row. 32 bytes. So that would probably be this whole row here. Would be the numbers 1 through 8 in hexadecimal. Computer thinks you might be trying to look at a word, so it just puts words in there. But I think there's a way to like even tell it that it's going to be an integer and stuff. I'm not really sure how to do that right now, and I don't really feel like looking it up. I could also put the memory address of the first element. Yeah, same thing. Memory address of the second element. That's not too useful to us today. Okay, so limitations with this were we couldn't insert numbers on the fly if we wanted to. We couldn't make it bigger as we went. We kind of needed to know the size at runtime and all kinds of stuff like that. That wasn't super beneficial to us, especially if we were going to work with graphics, because in graphics sizes are changing constantly in projects and stuff. So I'm just going to make a project here in SFML. If you can't get SFML working on your computer, don't worry about it. But remember the good old circle, green circle and a square, right? Let me show you how to make an array full of rectangles that will fill the screen. So I'm going to make a rectangle shape, and I'll call it shapes or something like that. And I'll just put, I think in the lab it said 5,000. So I've now made 5,000 rectangle shapes. Now, of course, it doesn't know how to draw that, right? So what I'll do here is I'll say I is 0, I is less than 5,000, and I basically I'm just going to put my window.draw in a for loop. I don't need the curly brackets because there's only one thing. And then I put shapes I, because shapes is the name. So it's going to draw all 5,000 every frame. It shouldn't slow down my computer at all. And they're all empty because by default, when you make a rectangle, it has a shape of 0 or a size of 0, and it's also set at 0, 0. Let me see if I can debug this and run it. Okay, let's have a look. Yep, let me go to my watches. I wonder if I go shapes 1 like this and type it in, or shape 0 and type it in like that. Yep, it knows it's a rectangle shape. It has a size of 0, 0, which is why we can't see it yet. It's got a bunch of other stuff because it draws it using like the 4 points on the corner, so it has to know where all 4 points are. It has to know its color and stuff like that. Apparently the color is white. It's just RGB values of 255. So you can look at that in the debugger too. It's nice and useful sometimes. But there we go. So let's make all of our rectangle shapes once we make them. So now basically every code we make has to have a for loop after it, because whatever we need to do to 1, we need to do to 5,000. And obviously we need to use a for loop to do that. So we're going to go through all of our shapes like this. Shapes I, okay. And then we'll hit dot. Now I don't know why that's not auto typing. Must have something wrong in here. Let me just see what's going on. Sorry, I got it auto typing again. So shapes, but I have to write I after it because now I have 5,000 of them, right? The for loop's going to take care of the 5,000, but I need to put the I in there for the index. I'll set all their sizes. Set size is still that it takes that awkward vector 2f instead of just 2 numbers. It's okay. We're all smart people. We can do that. And let's set them all to have a random position as well. Okay. So we'll set the position to, now my screen is 800 by 600. So I'll do rand %800. That'll give me a number between 0 and 799. And then maybe I'll say 801 because then my screen will go right to the edge. And then this one will be %601. So I'll always have a number between 0 and 600. Okay. Random won't work until you add these things. Include C standard library. And also include, if you want it to look a little different each time, you got to include time. Oopsie. Time.h, because the first line of our program, we want to shuffle the deck of our srand, and then we write time, and then we write 0 like that. This is not SFML commands, by the way. SFML has its own time variable with a capital T. C++ is this really weird built-in time one. That's the only use for it, I think, is for this shuffling. Okay. Let's see what happens here. There you go. 5,000 random dots on the screen. If you wanted to, because this is 800 and 600, there's actually 800 times 600 pixels, which is what, 48,000? 480,000? Can you make 480,000 in an array? There is a limitation to how big you can make an array because it stores it all in the RAM of your computer. So you can't just fill it up and have the computer not complain. 48,000. 480,000. Let's see if that It won't fill the screen because obviously we'll have repeats in our randomness, but it crashed. It does not like 480,000. I wonder what the error message says. I'm going to hit debug here and run it and see what line it crashes on. Received a segmentation fault. That doesn't even tell us where. No. Okay. So you can't make an array 480,000 for obvious reasons. You really don't want to store that much stuff in the memory of your computer. Maybe you do. There's lots of times where you would want to do that, but there's better ways to do it than storing it in an array. Let's try 48,000. See if it complains about that. Still crashes. How about 4,800? 4,800's fine. I wonder what the limitation is. Anyways, there you go. How would you, okay, so I had my 5,000, right? Here's my 5,000. Here's my 5,000. One thing I could do is I could make this variable, like I could make a counter loop. So let me try this here, where I say int, maybe something like frame equals 0, right? And then I just say frame plus plus, so it just keeps going up. And if I write this as frame, what will happen is it'll draw, the first time through the loop it'll draw 1, and then 2, and then 3, and then 4, and it'll kind of build it up. This is, do you see it? It's kind of like a starry night or something. It's going to eventually stop when frame reaches over 5,000. It probably, I don't know if it'll crash or not. You know, C++ sometimes will just try to access things that don't exist, and it won't really have an issue with it until you go to like use it per se, but let's see if I can make it crash. Pretty trippy. Still drawing them, so we're not at 5,000 yet. At 60 frames a second, it should take, I don't know, too long, so we won't sit around and wait for that. What I'm going to do though is, just for kicks, I'm going to set the random position inside of my loop. So I'm going to take this line here, okay, and I'll put it in a for loop right before I draw. Do I want to do it that way? Sure. I mean, I already have the for loop sitting there. All it's doing is drawing 5,000 times. So what if before I draw each pixel, I give them in the random position, then it'll just kind of look like static on the screen. Yeah, looks kind of cool, hey? If you've ever seen that before, static, it's called static. It's basically just random noise on your computer or on a TV or something where it's picking up, excuse me, comfortable, this chair's awful. Where it's just picking up random noise. And so that's what you see. You just see kind of random dots everywhere. That's why they call it static, or white noise is another word for it. Okay, kind of looks hypnotic to me. All right, so that's good. Arrays are not as powerful often as we need them to be. So I'm going to show you a better way to make an array, and in C++, it actually has a terrible name. It's called vector, and you include this vector library. Everything's the same. It works the same as an array, except for a couple differences, which is a couple of improvements. So this vector is just like an array. It just holds all the numbers in memory. But to make it, you write the word vector, okay? And then in pointy brackets, you write the type. So let's say I want an array of floats. That's what I would write, okay? And then you give it a name. So I'll call this one numbers again. Okay, there you go. And I think you can put square brackets after it to tell it how many you want. Like the last time I said 8, right? Oops. I'm going to run this program now. Just double click on it. Yeah. And I could still do everything I could have done once I've created it. It acts exactly like an array. So if I go 8 like that, and then I go I plus plus, oopsie, then I can make numbers I will equal I plus 1, and it's all good to go. Should do the same thing. Let me just debug there and see what it looks like. It'll look, no, I don't want to do that. Numbers I equals, what if I make this an int? Some very strange errors when you mess around with vectors. So I think actually this needs a circle bracket or a round bracket. There you go. Yeah, it's not square brackets when you make it, but it's square brackets when you go to use them. Okay, let's see what it looks like in memory. I could delete this. I'm not looking at that anymore. Delete. And then numbers is there. It says it has a length of 8 and a capacity of 8. So it's exactly like the array. A couple of nice features about it is, first of all, I don't have to put 8 here. Numbers has a size built in, like that, just like string. Okay, so that's super nice because an array never knew how big it was, and a vector does. It's called a container because there's a whole bunch of different types. The vector is the one we're going to use. So a vector knows its own size, which is really nice. The other thing that is nice is I can push back more values onto it. Like, let's say I push back the number 9 onto it, and then I push back is the command, and then you just pass it what you want to put on the back of it. Now when I run it, you'll see that, let me see here, watches. It now has a length of 10, right? And it allowed me to put 9 and 10 on it, which is cool. I can also delete the last item, and I can also erase items from it. That gets a little trickier, or we'll learn. But we can erase items out of it. We can pop back, which means take the last item off. So now when I run this, it should just be an array from 0 to, or from 1 to 9. Yes, see, the last element got popped off. Okay. I think one problem with it is, first of all, SFML uses the word vector a lot for its 2D numbers, so there is a little bit of a name clash there, which I don't like it that much, but it's fine. Another thing I don't like is you see when you make a little mistake in its nice little C++ way, especially when you're working with vectors, like look at this error. It's a complete nonsense, right? Anyone trying to learn how to code in C++, this is a huge barrier to them. These terrible errors. Request for member size and numbers, which is of non-class type std vector int. Okay, no match for operator equals. Oh, that's garbage. That doesn't mean anything. Should have just said, bro, this needs curly brackets and not square brackets. Okay, that's a hard thing to do when you're making a coding language, is like parsing all the words people write and trying to turn them into code and then try to figure out what they did wrong. But that is something to look out for. What else can we do? So this new array has all kinds of built-in stuff too. You can actually output the first number and the last number. There's like a dot begin and a dot end. There's a whole bunch of interesting things that you can learn and do it with. Dot front insert is another one where you can just insert it. You can resize it. So they're used more often than arrays for sure. Okay, and they're the same size in memory, I believe. Maybe a little bit bigger, just because you know, it has to store more information about it. Whereas the array, our array that was 8 numbers long, it's just 8 times 4 bytes, 32 bytes. This is going to be a little bit bigger. It has to keep track of the size and all that stuff. But I mean, computers are meant to handle little extra memories and things like that. So, okay, so have a look at the lab. and let me know how you do. I'll be, if you need to meet on Google Meet, just email me. No one ever shows up to those meetings, so I'll just email me during the day if you need help, and keep an eye on your projects as I mark them, and make sure you're finishing them, okay? And that's we'll do one more lab tomorrow, and then I think we'll spend the last 2 days just catching up on our work and getting stuff done. Maybe I'll post some things that you can have a look at, but don't need to be completed, kind of thing, right? Just if for general interest. If you want to take grade 12, we do a lot of graphics. We if you go File, New, you go Project, and Box2D SFML project. This has a physics file in there that I set up and created, actually. Look at Box2D API written by Verzinga. And it's just a whole bunch of functions. There's some weird words in here. I made it in a namespace as well, so that a lot of the functions wouldn't get confused with the names for SFML, but like you create a box, you create a circle, you can create polygons, you can create sprites. There's a function called display world. There's one called set block texture, set block color, check collision, filter collision, and all that. And then you can go through the actual, like the kind of hello world program here. And it's got some comments in there. So in grade 12, we work with this a lot, and we basically just make some fun projects in the course and kind of goof around. But you can see that it uses SFML to draw physics objects, and then it uses this physics engine to make them all smash into each other and stuff. So you can make some really cool stuff just by basically typing in. For me, all I did for this one was say, if the mouse button is pressed, this is SFML code. Go to your physics file and call the function create box, and just give the box a mouse position and a size, and it'll draw all those cool little pictures, and then you can basically make whatever you want with physics, and it takes care of a lot of the issues of collision. Cool, eh? So that's what we do in grade 12. Have a look at that. Experiment with that if that's something that interests you. And I'll talk to you tomorrow. Okay? Bye.